Welcome to React Events. I imagine all of you have had at least a little bit of experience with React Events so far. So what I'd like you to do is go ahead and Slack me all of your React event questions. If you don't have any questions, then brain dump. Tell me everything you know about React Events, and then we'll take it from there. Let's give that 3 minutes. Slack me questions, or if you don't have any questions, brain dump everything you know about React Events. All right, pencils down. Slack me what you got. All right, so let's take a look at it. This is what you shared with me. So some themes I'm seeing, lots on synthetic events. Hovering. Just other like non-click and submit events in general. Passing handlers. Debugging. That's synthetic events. A couple questions about capturing. Synthetic events, other events. There are no events that are special to React. It's just they're all DOM events. Capture, capturing, bubbling, stop propagation. Inlining versus extracting. Debugging, bubbling, synthetic events. Cool. So let's talk about some of this stuff. Let's start with synthetic events. So synthetic events aren't appreciably different than regular DOM events. They have effectively the exact same API. They are triggered by the same kinds of things. But the reason why we have synthetic events instead of DOM events, the reason why we can't do add event listener or any of that kind of stuff, is because in React, and in fact, all front-end frameworks, we're never working with the DOM. So this is our code. This is the DOM. In like mod 2, mod 3 kind of stuff, our code works directly with the DOM. In React, Angular, Ember, Vue, all the other ones, we have a virtual DOM. We write to the virtual DOM writes to the DOM reacts to that, updates the virtual DOM, comes back to our code. So like these are events. That's a synthetic event. That's an update, updating the DOM. That's an update. So the reason for this, I was actually here when the collective we in the web development world were starting with this virtual DOM stuff. So you've probably heard me say a bunch of times that the slowest thing in any app is the what?
Network requests.
Network requests. Like you can't get much slower than that. Even a pretty fast one is on the order of like a couple seconds. Like if you had things in your app locally that were taking a couple seconds, like nothing would ever get done. So we've got like that's the slowest thing. So doing things like eliminating network requests radically speeds up our app. The next slowest thing in your app, in a web app, is DOM updates. It's just a crazy fucking slow API. It was never meant for how we're using it. Another, like the DOM predates web apps substantially by like 6 or 7 years. The Web apps really came out of like, hey, what if we hacked this and we're able to make apps with it? But like everything on the web has to say backwards compatible. So we're stuck with this DOM update model that really doesn't match how we work with web apps. And so it turns out that if we're doing reactive code, meaning that we have state, and when the state changes, we want to re-render stuff. Re-rendering the entire DOM every time, unacceptably slow. So instead, what you do is you have this in-between thing called the virtual DOM. It works exactly like the DOM, except it never renders. And so what that allows us to do is say, all right, we're going to update the DOM, we're going to update the virtual DOM, update the virtual DOM, update the virtual DOM. And let's say we're making these updates every millisecond. We're making hundreds, thousands of these updates. What happens is React will periodically go, all right, what does the virtual DOM look like right now? And what does the DOM look like? I'm going to batch all of these changes. So instead of doing 1,000 updates to the DOM, I just do one big one. That's the purpose of the virtual DOM. Because we can work with this stuff in memory crazy fast if we don't have to actually render it. So we're trying to limit the number of renders that we're making. But the DOM is two-way. We can update the DOM, but we can also have these events that trigger behavior. Those come out of the DOM and we listen for them. So synthetic events are our way of dealing with that. We can't do an add event listener. Can't listen to an actual DOM event, but our fake DOM will let us know when a real event happened by sending us a synthetic event. That's how that works. Ask me some questions about it.
So are there points in a website where the DOM and the virtual DOM are like differ?
Yeah, absolutely. If you're making a shit ton of updates, like if something is writing to state really fast, React will batch those and go, hang on, before I update the real DOM, let me see if I can combine that DOM update with some other stuff.
Is there a way to designate like priority on your virtual DOM updates so that stuff renders singularly changes versus batch changing? Okay.
Yes, there is. That is all of those other lifecycle methods that we don't talk about. All of those have to do with performance. So you can limit how much the DOM is updating. You can make it update more often. You have control over some of that stuff, but it's performance tweaking.
So when you call an event, does that trigger a actual DOM change to get it to come down?
So let's say you click on something in the real DOM. That click is going to fire a click event that's going to get caught by the virtual DOM. And then the virtual DOM will emit a synthetic event that you can listen for. It has all of the same shit that regular events do, and it serves basically the exact same purpose, like it does. The difference is that it didn't actually come out of the DOM. It came out of our little weird abstraction. And we have to be careful with synthetic events. Like if we get an event.target, for example, you can't update that event.target directly. We can do things like event.target.text content equals. But if we do that, we're trying to bypass the virtual DOM. It doesn't work. So like that's the limitations to synthetic events. We can't use them in every single way that we used the regular DOM events for. But events are just supposed to be signals. If you just use them as signals, they work exactly the same as regular events. More questions about synthetic events or the virtual DOM?
How expansive is the virtual DOM? Are there limitations on the size that it, like, I mean, other than processing power or memory? Like, I guess I'm not explaining that right.
No, that would be the limit to it, because
Yeah.
all of this happens in your RAM rather than just like on your screen. So yeah, that's a limit. But this is what the React library is it's handling all this shit for you so that you don't have to write that code. Now, you might hear this word get thrown around every once in a while. It's not the same thing. In fact, it has nothing to do with it. There's also a shadow DOM. Shadow DOM is part of the real DOM. And it's like not relevant to anything we're doing in this program. I wouldn't worry about it. But it has to do with why, like, if you do an input tag, it's got all this shit in it that like you could style separately. It's got a lot more going on than like a div tag does. It's because that element has its own little private DOM inside of it. It is mega tweaky, don't worry about it. But it's not the same thing as the virtual DOM, should you happen to come across that term. Other questions about synthetic events? Done. Inlining versus extracting. My advice to you is, with one exception, don't inline your event handlers. The exception to that would be if you're if all you're doing is calling a method on it. Problem is that when you inline these things, you get something like all right, so we take in the event from the on click, and then and here this turns into event dot prevent default or stop propagation, do something else, do something else. So now our code has like two completely different things happening in the same syntax. I have like full JavaScript kind of shit happening inside of the HTML. That's a lot of context switching. That's a lot of knowing which thing you're closing which time. I mean, this last line here, the first curly brace closes a JavaScript function. The second curly brace closes JSX. And the third angle bracket closes an HTML element. Fuck me, man. That sucks. Versus if outside of all of that, we have something like click handler event, and then we do all of this stuff. In there, and now this just becomes way easier to read that. So in general, you should pretty much always extract your handlers. I said there's an exception, and there is. And this one actually comes up on the code challenge. If all you're doing is calling some other function when that gets clicked, I think it's okay to do this. Because onClick still needs a function definition, just like add event listener did. So if I do something like this, that don't work. Why doesn't this work?
Because it's not a function. It's just returning whatever that function evaluates to.
Right. So if what that returns, what that function execution returns isn't a function, you're going to get an error. So this is the like escape hatch around that. I'm okay with that. For everything else, you should use this. Questions about that?
So if I'm understanding that correctly, if you have the actual function itself in there, you just put the click handler in it. But if you are moving that function to a different component and then calling it, then you need the function and then put that function as the definition.
Yeah, so you'll pretty much never pass in something that works with the event directly. You could, it's not a good idea. You'll pass in things all the time that are like this. So it's totally likely that you might have a this.props call some function. I'd say that's even pretty likely. Anything where you might prevent default or stop propagation or something like that, that you're probably going to handle in the same component, even if the next thing you do is call this.props.call some function. But any kind of like event where you're working with the event directly, and that's usually going to be something like prevent default or stop propagation, you should probably do that on the same component that fired the event to begin with. You got more specific logic? Cool, pass that in as a prop. But handle this part of it in that component. What else? Other questions about inlining versus extracting? Cool. So good on that. Let's talk about passing handlers. So probably said something like this a week and a half ago to you that you weren't ready to hear. So hopefully we're in a little bit of better headspace now for this. You imagine your component hierarchy is a bunch of squares. So this is component 1, component 2, component 3. Let's say there's some state on this outer component. That maybe it gets used in component 2, and there's a button in component 3 that can change it. So the way this works, state gets passed in as a prop here. This is the important part. The means to change state, functions that change state, functions that call set state, anything that changes this has to live next to the state. Whatever that function is, it has to be right next to state. If some other component is the one that changes that, then that function needs to get passed. And you can pass it wherever you want, doesn't matter. But these two things need to be defined next to each other. They don't have to travel together. Where your state goes and what things can update the state don't necessarily have anything to do with each other. But both of them get passed as props. What I think is confusing in the React world is that they use that phrase data down, actions up, which I think more closely describes how it gets used in every other framework. I think that React does it more data down, actions also down. Basically, you're taking this function definition, passing it in here, you pass it again through here, and now this function can call this function whenever it wants. Can anybody tell me how it does that?
Event bubbling.
Closures.
Closure. Event bubbling is how it happens in every other framework. React does not do event bubbling, period, the end. That's another difference between events and synthetic events. They'll bubble within a component or something, but past the component boundary, they don't go any further than that.
So it's because like you've defined that function that changes state in like component 1 in this case, and because components 2 and 3 live within that component, that's what creates the closure. It's the component 1 that wraps around everything. Kind of, you can think of it as one big function.
Exactly. Other questions about how we pass in these handlers?
There's no problem if you wanted to call it in component 2 and component 3. That's
totally fair.
Do whatever you want.
Yep.
Yep.
But anybody who needs to be able to change this state just needs to have this function. More than one person can have it. That's fine. Like, let's say this change state thing is a reset, and you can reset something from all over the app. All right, well, it gets passed into all the components that need to be able to do that.
Is closure kind of how a lot of the other SPA frameworks work, like Ember and like Angular and stuff like that?
Pretty much all of them allow it because it's the only way you can do stuff in React. And if you want to be able to accommodate developers coming from React, got to be able to do these goddamn closure actions they like so much. I think the more sane way to handle it is have components emit their own events. And so, all right, I want to do a reset. Well, this component can say, yo, I'm emitting an event called reset. And this outer component listens for that event, even if all it's doing is just bubbling it. Goes, cool, I got an event that said reset. I don't have anything to do with that, but I'm going to keep bubbling it. Hey, component 1, here's a reset event. They go, cool, I'm listening for that. Well, whenever I get that event, I call reset. That's the other way that problem is solved in other frameworks, but components can't emit events in React. Only actual elements. Other questions about how we pass functions around?
So to give that component 2 that state so that component 3 can have a change of state, you would pass the state down as a prop to prompt or comp to set it as the state and then pass along the, am I understanding it wrong?
Something's state is only state in one place. Anybody else who wants it, it's props.
Okay.
So in this case, this data is state up here. If I pass it in here to comp2, it's props. You never do something like save your props to state. That's always the wrong call. And something having state and something being able to change state don't necessarily have anything to do with each other. This thing needs state if it's going to like show it. Otherwise, you can pass in this handler, this set state function. You can send that somewhere that doesn't also get the state. That just gives it the ability to change the state. Maybe some completely different thing is using the state.
But then if component 3 changes a state, component 1 becomes aware of it, and that's your but that still is your action up, right?
That's what action up is supposed to mean. Yeah, this thing, that was terrible. This thing calls this function. This state changes. This state change triggers a re-render in component 2 because it depends on that state. Anytime this changes, anything that depends on that state re-renders.
By something that depends on the state, do you just mean like something that has it as props, or it has to use the props?
That's a good question. I actually don't know if it makes a distinction between those two things. This is part of what the virtual DOM is all about, where the virtual DOM is making a decision on whether or not to actually re-render it. It might go like, well, I have this prop, I don't do anything with it, so I'm not going to waste a re-render on that. Or fuck, maybe that's a hacky way to force something to re-render is give it a prop even if it's not using it. Not super important. But yeah, it knows that component 2 depends on component 1 because it gave it some of its state as props. And when this state changes, component 2 reacts to the change. It's the titular line. Other questions about this? I just thought of another analogy. If this doesn't help you, throw it away. But I'm imagining this being a scenario where, like, I'm holding a speaker, and then I give Sydney the remote, and then Sydney gives Jen the remote, and then Jen hits a button and turns it on. It's kind of like, this is the function, and Jen's calling the function, even though it went through 2 people to get to her. You have more than one remote control, just give them out to a bunch of people. Any one of them can hit a button, make the stereo start playing. Other questions about how we pass around handlers? All right. So let's talk debugging real quick. So when you're debugging these things, it's not super special. The thing that gets kind of confusing sometimes is you're defining this function here, but you're calling it here. So if you want to find out what happened in here, that console log needs to be in this function because that's the function that's getting called. So let's take a look at that one in action. My good internet's back. So we're going to model this thing here. Component 1, component 2, component 3. All right. All right, so I got this guy here. I'm going to make a couple components. Let's get rid of all of this. There we go. This one's going to bring in component 2. This one's going to bring in 3. Oops. Gave myself a good old infinite loop there. And last one. Cool. Got it. Same hierarchy as this. So we're going to put some state in component 1. And oh no, this is a function. So I got to classify it. Which means throwing this in making it a class and throwing this in a render. All day, all long. You should be able to turn stuff into functional components, into class components, back and forth, just like that. So let's say I give this some state. Is light on? False. Okay, so I've got a light. And I want to pass that as state to component 2, just like I did here. So I say this dot state dot is light on. So now is light on is a prop of component 2. I could have called it something else. You can change the name when you do these things too. It doesn't matter. All right, so component 2 knows that it has this prop. So in this example, we're using that here. So maybe so I could say something like props is light on. If it is, it does that string, otherwise it does that. Just conditional rendering. I don't have to keep passing that into 3. Cool. We can even see that change in real time. If we go back over here, there it is. So we have a reactive app now. Now, let's say we have a toggle light. And so it's going to say this dot set state, whatever is light on is currently set to do the opposite. Actually, I'm gonna have a bad time if I don't fat arrow that. Okay, so now that function, I can send that wherever I want to. Could send it to component 2, could send it into completely different component hierarchy if I want. I'm just passing the function definition down. Now I can say toggle light. What do I call it? Yeah, toggle light. Props dot toggle light. Cool. So now component 3 has that available also. So let's say I put a button here. I can say on click props.toggle light. Is that going to work?
No, because it hasn't been properly passed down, right?
It's probably been passed down. That's not the problem.
You don't have a function, you've got a return function.
Bingo. I have whatever that function returns, which is nothing. So if I did want to do that, I can do that, and I'll bet that works. Pew, 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 pew. It's working. I could also extract that. Have something like button handler and all it does is call props.toggleLight. Now this becomes button handler. Does the exact same thing. Okay, so our original question was about, so just to be clear, this is exactly what we did. We have some state here, we passed the state into here, did not pass the state down here. We have a function that changes the state, we pass it there, we pass it there. So let's say I want to debug this. I can put a console log here. There it is. If I want to see it like at the function that's actually changing the state, I can put that in here. There it is. But that's happening because this is a function definition. That definition was passed into component 2. That definition was drilled down into component 3, and component 3 was the one that actually called the function. So you can debug stuff that way. Questions about that? Cool. That's debugging. All right, let's wrap up with capturing, bubbling, and propagation. All right, this isn't components, this is elements, this is DOM elements. When I click here, browser is going to go from the outside, checking for an event listener on everything on the way down. That's the capture phase. Then it keeps doing that till it gets to the element that actually fired the event. And then it goes all the way back up in what we call the bubbling phase. So 3 parts to any event firing. Capture phase, the event fires, bubbling phase. And just like in a capturing phase, it's asking each of these elements, are you listening for this event by chance? Gives them each a chance to do something. So your event listener can fire here or here. You can also add the event listener twice and do it on both phases if you wanted to. And that's just JavaScript. Well, that's the DOM. There's nothing React specific about that. Stop propagation is in any of these points, we can say, okay, cool, now stop going. On our way down, we can listen for an event here, handle it, and then go, cool, by the way, don't keep going down. We can just stop it right here. Same thing with bubbling. Goes up and up and up, hits one of these and goes, okay, cool. You don't need to keep bubbling up. There might be an event listener I don't want to trigger, so I don't want you to keep going. That's what event.stopPropagation does. The only React specific thing is that we listen for stuff in the bubbling phase with on whatever the name of the event is. For the capture phase, literally just add the word capture at the end. And vanilla JavaScript, you do that with your add event listener by adding a third argument. A string, that's the name of the event you're listening for, the function you want to fire whenever that event happens, and then true as the third argument. Any truthy value in that third argument will add the event listener to the capture phase instead of the bubbling phase. Ta-da! Ask me some questions about capturing, bubbling, propagation, that stuff.
So does event bubbling only happen like if you have two like elements or whatever, like watching for the same element, like an on click? Like say you have a like button that's waiting for an on click and then a whole card that you can click. Right. So it's like, it has to be looking for the same thing.
Right.
Okay.
The bubbling happens regardless, but it won't get intercepted. Nothing will happen to it if there aren't multiple listeners for that same event.
Okay.
To wit, so I have this click here. It gets handled here. Also, technically, like all of this, if you clicked on this, you also clicked on everything else. That's what the bubbling phase kind of stuff is all about. So I could say in component 2, let's say I make another handler here. That's like another click handler. And this one fires whenever anything in component 2 gets clicked on. Like that. So if I click on this button, I clicked on the light, but I also clicked on component 2. They're both listening for that click event. So I got it right here where the event happened, and I got it after it had bubbled. Womp womp. What if I don't want it to keep bubbling? Well, down here, I can do event.stop propagation. And now it's not going to keep doing that. Only the first one fires. Keeps it from continuing to bubble.
Did you put that on component 3, the innermost one?
Yep.
Okay.
If you threw a stop propagation capture event on 2, would that then
Yeah.
shut you down from clicking the button on 3?
Brian gets it. So if this instead becomes on-click capture, now I would expect this one to be the only one that fires. And it is. So the outside one fired. I caught it on the capture phase and then kept it from going any further. So it never actually got to the inner component and didn't have a bubbling phase.
So it doesn't bubble at all. Like it's
Correct.
not then bubbling from 2 back to 1. Okay.
Right. I caught it on the way in. So that's how you can use bubbling and capturing to control something on the outside firing when something on the inside fires. Figure out which phase it needs to be in, and then you can use stop propagation to keep it from continuing to go. I take off stop propagation. They both run again. You'll notice that the outside one, the component 2 one, ran before the component 3 one. That would make sense. Hit this on the capture phase, hit the other one on the bubbling phase. This one, if I take the capture off, those flip around. Component 3, component 2. Cool. Any other questions? All right, as a bonus, that like on syntax, it works with any DOM event. So like there's a question about hovering or something. So a hover is a like on mouse in, mouse over, DOM mouse over. There is a mouse over event. Cool. So let's say anytime I move the cursor over component 2, I want that state change to happen. So I can add an on hover handle hover. Cool. So right off the bat, like that works. Oops. Oh, not hover, mouse over. On mouse over. Oops. All right, so nothing. I go over it, and there it is. So let's say I want some awesome interface where every time I hover over it, it toggles the thing. Easy enough. I have something called props.toggleLight. Props.toggleLight. There we go. State change of mania. That'll work with any DOM event.
Are you able to target all of these like you could with original events, like pseudo selectors and CSS, shit like that? Like,
no, it has to be on the actual element.
okay.
The only way you can attach events in React is with this on syntax.
If you're listening for a ton of events, can that slow your app down?
Yeah. Like, I wouldn't worry about it until like it's actually happening, but we can do similar things. I don't know if we talk about event delegation at all in Mod 3, but event delegation is a way to handle that. Like, let's say you had 1,000 list items and you want some like common behavior to happen with each one of them. So you can add 1,000 event listeners, or you can delegate that. So what that means is if we have this list and it's got all these LIs, instead of having a listener for every LI, you put the listener here instead and wait for it to bubble. And what you inevitably have to do is go, okay, well, which one got clicked? Well, you can use event.target to figure out which one got clicked. Event.target.dataset.user ID or whatever it is, and use that to pass that into a function or do whatever you want. But the way you improve the performance by only having one event listener instead of 1,000. And it catches all those individual events and stuff through bubbling. Event delegation, name of that pattern. Jay asked, what's the Linux command to shift an app to the side? Do you mean like that? Jay, is Jay still on the call?
Yes, that's what I meant.
You have to customize it, but it's not a plugin or anything usually. If you're using Ubuntu, you can go to keyboard shortcuts and then navigation and move, oops. It's view split on the left, view split on the right, but like I had to assign keys for it. And then this one is toggle maximization state. I stole all three of those from Chrome OS because Chrome OS has those, and like I was like, oh, that's exactly what I want. And like it ends up being yet another reason that I cannot fucking use Mac OS. Because if you hold shift while doing any other key combination in Mac OS, it does it in slow motion because of some tech demo that Steve did 15 years ago where he wanted to show that they actually tweened or they were actually redrawing the things instead of doing tween frames. and now I can't do my goddamn key command the way that I want to. I tried like disabling it as low a level as I could in macOS. I never got it working. But yeah, in Linux, it's just here.
Thank you. That's awesome.
It is awesome. Any other questions? All right, go pass the code challenge. Bye.